DC load line. And what all the which will shift your Q point. We have seen this already. One is IC naught, reverse saturation current, which will double for every 10-degree rise in temperature. We have seen this yesterday. Another one is VBE. VBE will also decrease by 2.5 millivolt per degree Celsius. So if 1 degree Celsius is increasing, VBE will decrease by 2.5 millivolt. And last one, HFE. HFE is the current gain which will increase with temperature. So you see two parameters increase with temperature, one parameter is decreasing with temperature. So if we are going to use the semiconductor in a hot place or in a very cold place, then you have to be prepared to handle these three parameters, because normal room temperature is 27 degrees Celsius. When you are going to keep this device in a desert where the temperature is 45 or 50 degrees Celsius, then you have to consider all these parameters before you design your circuit. So at 45 degrees Celsius, IC naught will be very high, VB will be very less, beta will be very high. So accordingly, your biasing circuit parameters VCC, RC, and RB will change. You cannot use what you use in the room temperature. If you are going to use the same amplifier in a polar region where the temperature is sub-zero, below 0 degrees Celsius, there this IC naught will decrease, VB will increase, beta will decrease. So in that case, you have to consider those values of parameters for designing your biasing circuit. In that region, the values of VCC, RB, RC will change. So what is understood from this? Nothing is fixed. So because your transistor parameters are temperature dependent, all the biasing circuit parameters will be changing if the temperature is going to play an effect on your circuit. So be very, very clear that once you design your Q point, it is not enough. You have to maintain the Q point, and you have to also ensure that the temperature variations are considered while designing my operating point in my BJT.